Okay, you're given this function, y equals x over the square root of 1 minus x, and we're told that it has a tangent line with an equation that looks something like this at the point where x equals -3. Find the values of a and b. Okay, and here's a picture from Desmos that indicates what's going on. Here's the function. When x is -3, y is -3/2, so there's the point of tangency right there. And if we find f prime of -3, we get 5/16. That's the slope of that tangent line. So we know a point and we know the slope, so we can use point slope to find the equation. So let's see the steps involved in making that happen. So again, f of x is this function right here. We want to find the y-coordinate of the point where x equals -3 so that we have the point of tangency. If we put -3 in for x, we get -3/2. So there's the point of tangency right here, POT. Now we have to find the first derivative and find its value at -3, so we have the slope of the tangent line. So we have to use the quotient rule. So here's the denominator times the derivative of the numerator is 1. I didn't show that 1 here. Minus the numerator times the derivative of the denominator. Here's the derivative of the denominator. We use the power rule, bring the exponent 1/2 down front, reduce the exponent by 1, and multiply by the derivative of the inside. That's the chain rule over the denominator, all over the denominator squared. I can rewrite this term right here. -1 times this minus x gives us a plus x. And then we have a 2 in the denominator, and we can move the 1 minus x to the minus 1/2 to the denominator. And you could find f prime of -3 right from here, but just to simplify the derivative a little bit, we could multiply top and bottom by the common denominator of the complex, or the fraction that makes this a complex fraction. So this is what you're visualizing. So when I take 2 times the square root of 1 minus x times this first term, I just get 2 times 1 minus x. When I take it times this term, the entire denominator cancels out, and I just get this plus x. And in the denominator, I get 2 times 1 minus x to the 3/2. And the numerator simplifies to 2 minus x if you remove parentheses. So there is probably the simplest form for the first derivative right there. And here's f prime of -3. -3 in for x gives us 5/16. We've got the slope of the tangent line. We've got the point of tangency. Use point slope. Y minus y sub 1 equals the slope times x minus x sub 1. I would multiply every term by 16 on both sides of the equation to clear the equation of fractions. So 16y plus 24. Over here, when I multiplied by 16, these 16s canceled out, so I distribute the 5. And if I transpose this term to the right side and the 15 to the left side, I get 9 equals 5x minus 16y. Using the symmetric property for equality, I can rewrite it like that. So there's your values of B and A. Okay, there you go. Hope that helped. If you have any questions, post a comment.